Okay, in this video, we're going to continue with case 3 and case 4. Okay, so case 3 is irreducible quadratic factors or prime quadratic, where the denominator has irreducible quadratic factors. I mean, you cannot factor it anymore. Okay, so for example, I have 3x squared minus 7x minus 2 over x times quantity of x squared plus 1. So for this example, the denominator is already factored for you, so that's good, right? However, if you notice that the factor x squared plus 1, so this factor right here is quadratic and is irreducible quadratic factors, right? So you cannot factor it anymore, right? So in this case, I have two factors, so I'm going to write my decomposition as something over x plus something over x squared plus 1, right? So remember, I said that the degree of the numerator has to be 1 less than the degree of the denominator, right? So for the first fraction is just a over x, right? So because x is a 0 is a constant. For the second fraction, it's going to be bx plus c. Okay, so why? Because on the top is x to the first, and on the bottom is x squared, so 1 degree less than, right? Okay, so now we're going to do what we usually do, right? The common denominator. So if I multiply both sides by x times x squared plus 1 over 1, we write this number 1 neatly. Okay, the left-hand side does just cancel, so it's 3x squared minus 7x minus 2 equal a times x squared plus 1 plus bx plus c times x equal to ax squared plus a plus bx squared plus cx. Combine like term and factor the common factor. So I have a plus b quantity times x squared plus cx, the x term, and then plus a constant, which is a. And the left-hand side is 3x squared minus 7x minus 2. Okay. And we talk about this. The left-hand side, the coefficient of the left-hand side needs to be equal to coefficient of the right-hand side, right? So this is imply I have a plus b must be equal to 3, right? And then c is equal to -7. And a is equal to -2. Well, if a equal -2, what's c equal to? I'm sorry, b equal 5, right? b equal 5. Okay, so there we have a, b, c. Okay, so if I were to write this, it's going to be equal to I don't want to rewrite the original problem, so it's just gonna equal to -2 over x plus bx, which is 5x, plus c, which is -7, so -7 over x squared plus 1. Okay. And that's how we do the partial fraction decomposition with the prime quadratic case. Okay. Okay. Case number 4 is improper partial fraction. It's called improper because the degree of the top is greater than the degree of the bottom, right? So notice that from case 1 to case 3, the degree of the top is always less than the degree of the bottom. Okay, but in case 4 is the opposite. So what do we do? When you see this situation, what you're gonna do is you're gonna do long division. Okay, so long division. So let me set up. So I have 2x cubed plus 6x squared. Maybe I'll do this in plus 5x minus 7. Long divide into x squared plus 2x plus 1. Now notice that, maybe I'll do this in blue. Now notice that when you write out the dividend, by the way, the dividend is this guy, okay? That's your dividend. Make sure that every degree is included, okay? So hypothetically, if I don't have the x squared term, for example, I don't have the x squared term, so scratch that off, right? If I don't have 6x squared, so what I'm gonna do is I'm just have to put 0x squared here. Okay, so make sure that every degree of the dividend is being included. Okay. Let me put 6x squared back. Now we're going to long divide. All right. So first of all, we're going to take the first term. So we're going to take 2x cubed divided by x squared. Right. So what do I have? I have 2x cubed divided by x squared is x, 2x, right? Is 2x. And then you multiply it back. You multiply back to the divisor, right? Oh, by the way, that's the divisor. Right? So 2x times x squared is 2x cubed. 2x times 2x is 4x squared. And 2x plus times 1 is 2x. And then, oops, sorry. And then we subtract. And then we subtract. Okay. Make sure when you subtract, you want to subtract every term there, right? So 2x cubed minus 2x cubed, 0, right? 0. 6x squared minus 4x squared is 2x squared. And then 5x minus 2x is positive 3x. And let's bring down the 7. Minus 7, bring down the minus 7. All right, same thing, we take 2x squared. We're going to take this one divided by x squared. So 2x squared divided by x squared is 2. So positive 2. 2 times x squared is 2x squared. 2 times 2x is 4x. 2 times 1 is 2. And subtract. Um, 2x squared minus 2x squared is 0, right? 3x minus 4x is minus x. And then negative 7 minus 2 is negative 9. All right, since this one have a lesser degree than the divisor, then we stop here. So that is your remainder. Okay, this one right here is your remainder. So we're going to rewrite it as, so we're going to rewrite this. So let's rewrite this. Rewrite this. It's going to be equal to, so the quotient is 2x plus 2 plus minus x minus 9 over x squared plus 2x plus 1. Do you remember this form when you long divide of fraction that have variables? The form will be what? The form if I had px divided by dx. Px is the dividend and d of x is the divisor. It's going to be equal to q of x, which is your quotient, plus r of x. R of x is the remainder over the divisor, d of x. Okay, so quotient here is 2x plus 2. And the remainder is negative x minus 9. And the divisor is x squared plus 2x plus 1. Okay, so nothing we can do about the quotient here. We're done with the quotient. But one thing we can take care of is we're going to break apart the remainder quotient, right? So we're going to break apart negative x minus 9 over x squared plus 2x plus 1. Right? We're going to break that guys apart. Okay, so let's do that. Let me divide this part here so it doesn't look tangling all together. Okay. All right. Okay, so we're gonna take care of that one that I circled. So let's rewrite this: negative x minus 9 over x squared plus 2x plus 1. If you factor this, what do you have? X plus 1, which is x plus 1 squared, right? X plus 1 times x plus 1 is x plus 1 squared. So this is case number 3, right? I think it's case number 2. I'm sorry, case number 2. Repeated linear factor, right? So it's going to be equal to, so this is going to be equal to, now this is going to be equal to a over x plus 1 plus b over x plus 1 squared. Okay. Maybe let me bring this down like this so we can do the common denominator. I'm sorry, yeah, the common denominator. Move this to the right a little bit and duplicate this one. There you go. Okay, it'll look better. Okay, LCD. The LCD is x plus 1 squared, right? So it's x plus 1, oops, x plus 1 squared over 1, and then you distribute into each of fraction. So on the left-hand side, just negative x minus 9 equal a times x plus 1 plus b. So negative x minus 9 equal ax plus a plus b. So this implies a equal negative 1. Oops, sorry, a equal negative 1. And then a plus b equal negative 9. Well, a equal negative 1, so b equal, so this implies b equal negative 8. Okay, so the final answer, is I have 2x plus 2, so this is rewrite the quotient there, 2x plus 2 plus the one that we break apart is a over x plus 1, so negative 1 over x plus 1 plus negative 8 over x plus 1, all of that squared. And that will be our final answer. Okay, thank you for watching.